5.5, number 4. So if they didn't tell us this, we would be factoring that, and I see an x squared in both of those. And if I pull it out, factor it out, I get an x squared times x squared, x to the fourth, plus 16. So this is a repeated linear factor. That's x times x. So they did x, then x, since it's repeated, you have to go squared, and we have that factor. That's a linear factor, and that's a linear factor that's squared, but so it just gets an a and a b. And this is a quadratic factor that doesn't factor, so it gets a degree less cx plus d, degree 2 to degree 1. And we're going to find what a, b, and c are. To do that, we have to think about what I would have to multiply to get a common denominator. Well, this is my common denominator. And I have an x squared, so I need a x squared plus 16. This one, I have only an x, so I need another x and an x squared plus 16, so that's x cubed plus 16x. And this one has an x squared plus 16, but it doesn't have the x squared. So, to solve for a, b, and c, and d, I see that I have x cubes, and I have x cubes down here, so I am going to have x cubes, 6 of them, is equal to ax squared, so that's an x cubed. There's a bx cubed, so 0 plus bx cubes. I like to use capital letters because a small case b looks like a 6. So plus 1b, 1x cubed there, 1bx cubes. X squared times cx would be x cubed, so plus cx cubes, and nothing for the d's. X squareds, 6 of them, a of them, no b of them, that's x cubed and that's x, so there's none for b. C, there's no x squareds, but there is a d x squared. X's, I have 48. I have no x's on A. I have 16x times b, so 16b. C is times x cubed, d is times x squared, so that's none other places. All right, and then the constant is 48. And 48, constant, let's see, got 16a. Both of those have x's, so no constant there. Both of these have x squared, so there's no constant there, so I just have this. Well, 16 goes into 48 3 times, so a equals 3. 16 goes into 40, b equals 3. B plus c equals 6, and if b is 3, that means c is 3. And a plus d is 6, and if a is 3, d must be 3. So now all we have to do is evaluate the integral, which means we have to evaluate the integral of this. So we have the integral of 3, 1 over x squared, plus 3 integral of 1 over x plus, I'm going to split this up, 3x over that, 3x over x squared plus 16 plus 3 over x squared plus 16 dx. So I got to find the antiderivative of each of those. Well, this is the same as x to the minus 2. So if I evaluate that, I add 1 to the power. That's x to the minus 1 divided by minus 1. That's simply minus 1 over x. So times 3, so it's minus 3 over x for the first one. This is x to the minus 1, which you can't use the power rule on, but that's ln, so it's plus 3 ln x. This, if I do u equals x squared plus 16, du would be 2x dx, and so divide by 2x. So dx would have a 2x in the denominator, the x would cancel, and I'd get a 2 under that, so I'm going to get 3 halves integral of 1 over x squared plus 16, that's u, 1 over u du, and that would be 3 halves ln of u, but u was x squared plus 16. So that's that one, plus the last one. Now, if it was x squared plus 1, it'd be arctangent. And it's close to arctangent. We need to look at our formula page here. So we'll pull one of those out, see if we have a formula page for that. So we got x squared plus 4 squared. 1 over x squared plus 4 squared. So a is 4 and u is x. So 1 over 4. 3 times 1 over 4 arctangent where to go? Right here. A squared plus u squared, or u squared plus a squared, is 1 over the constant that's squared, arctangent of the variable over the constant, so that would be x over 4 in our problem. Plus, that's times 3, plus c. Okay, number 6. So let's just do these as practice, and then you could use the CAST system if you want, but we're going to factor the denominator. So x to the 4th minus 1 is x squared plus 1 and x squared minus 1. This doesn't factor. This factors to x plus 1 and x minus 1. So that's the denominator completely factored. So I'm going to have an ax plus b over this quadratic factor. I'm going to have a constant over x plus 1 plus a constant over x minus 1. You could write these in any order. you just got to match up the c with the x plus 1. The constant you get here should be over x plus 1. The constant goes over x. Yeah, got to match them up. So, to get a common denominator, which is this, we can see that this one is missing these two. And those two multiplied together is x squared minus 1. This one has this, but it doesn't have that or that. So I'm going to multiply those together. That's going to be x to the third minus x squared plus x minus 1. And this one has the minus 1, so I need the plus 1. So that's x squared, x to the third plus x squared plus x plus 1. And that's got to equal this. So there's 1x to the third. And here we have ax to the thirds. No bx's to the thirds. Cx to the thirds. And dx to the thirds. X squareds. That would be b. Oh, over here it's none. None from the a. B would be 1. X squareds, we have minus c. And x squareds, we'd have plus d. X's, we'd have minus a. Over here, x's, we have 1. Minus a. X's, for b, there's none. Plus c, x's, there'd be c of them. And x's here, there'd be plus d. And for the constant, which is 1. And a won't have a constant because it's got an x. B will be a minus 1. We'd have a minus c. And a d. Pulling out my calculator. Let's figure out what A, B, C, and D are. So this is going to be, my A will be a 4 by 4 and 1011 0 1 negative 1 1 negative 1 0 1 1 0 negative 1 negative 1 1. And hopefully I didn't make any mistakes. I can make rates. B needs to be, oh, I don't want it there. Matrix, edit, B, there. This is going to be 4 by 1, 1 0 1 1. Quit matrix A inverse matrix B so A is 0, B is minus 1/2, C is 1/4, and D is 3/4. So now let's go to the integration. So I'm going to split this up over this. So 0 x's over this, so there's no integral from that, plus b, which is minus 1/2, integral of 1 over x squared plus 1, plus c, which is 1/4 of 1 over x plus 1, plus d, which is 3/4, integral of 1 over x minus 1 dx. So, this looks like arctangent, so we got minus 1/2 arctangent x plus, if I did a u sub for that, that would be 1 over u du, and so I just get ln of x plus 1. 1/4 ln absolute value x plus 1 plus 3/4, same thing if I let u be this. Du would be equal to dx, and so I just get ln of x minus 1, because I'd get 1 over u du. So there's that one. That's A on 6. B on 6. Okay. Since the numerator is higher degree than the denominator, the first thing I got to do is long division. So I got to take x to the 5th plus x to the 2nd plus 3 divided by x to the 3rd minus 6x squared plus 11x minus 6. And x third times x squared makes x to the 5th, so I'm going to multiply this. X to the 5th minus 6x to the 4th plus 11x third minus 6x squared. Draw the line and change these signs so that I can think of this as an addition problem. So these will cancel. So I got plus 6x to the 4th, none other. I got a negative 11x to the 3rds and none other. And I have 6x squareds plus an x squared, 7x squared plus a 3. What do I have to take x to the 3rd times to make 6x to the 4th? Plus 6x. 6x times that is 6x to the 4th. 6x times that is minus 36x to the 3rd. 6x times that is 11x squared. And 6x times minus 6 is minus 36x. Draw the line and change the signs. And add the like terms. Those cancel. Minus 11 thirds plus 11 x to the thirds plus 36, so that's 25 x to the third. That'd be minus 4x squared plus 36x plus 3. X to the third goes into this, so that would be 25. 25 times that, 25x to the third. 6 times 25 is 150, so negative 150 x squared. 25 times 11 is 275. And negative 6 times 25 is negative 150. Draw the line, change the signs. And I get, those are gone, 146x squared. 75 minus 30, so negative 275 minus plus 36. Negative 239 x plus 150. I think that's right. This won't go in there, so this is my new denominator of this part. X to the third plus 6 minus 6x squared plus 11x minus 6 divided by that. Yeah, I'm just thinking about what I got here. Oh, no, my remainder, this goes on top over this. Yeah, there's what I'm thinking backwards. I'm a little bit sleepy here. Okay, so we're going to integrate x squared. We're going to integrate 6x dx. We're going to integrate 25 dx. Then we're going to integrate this, negative 146x squared minus 239x plus 150 over what we were dividing by, x to the third minus 6x squared plus 11x minus 6. This one's easy. X to the third over 3. 3x squared. 25x plus this. And now we finally have to do integration by partial fractions. So we need to factor that denominator. For an assist, type in x to the third minus 6x squared plus 11x minus 6, zoom 4. I see 3 solutions, which is nice for a cubic. Looks like it factors to x plus 1, x plus 2, and x plus 3. No, x minus 1, excuse me, because it has to, 1 has to make it 0. X minus 1, x minus 2, and x minus 3. So we're going to have a over x minus 1, b over x minus 2, and c over x minus 3. And it's got to be that in the numerator. This one is missing these two. Those multiplied are x squared minus 5x plus 6. B is missing these two, which is x squared minus 4x plus 3. And C is missing these two, which is x squared minus 1 minus 2 minus 3x plus 2. And so this has got to equal this. Well, x squareds, we have 146 if I didn't make any mistakes, which is highly probable that I did make a mistake, but we'll see. 146 equals x squareds, a plus b plus c. X's, I had negative 239 equals negative 5a minus 4b minus 3c, and constant. 150 equals 6a plus 3b plus 2c. Okay. So calculator. And so I have matrix A, second matrix, I don't want that. Matrix, edit, A, it's a 3 by 3 this time. 1, 1, 1, negative 5, 2. What did I do wrong? Negative 5, negative 4, negative 3, 6, 3, 2. Second matrix, edit, B, it's going to be a 3 by 1, and I'm going to put in 146, negative 239, and 150. And I'm going to do A inverse matrix B, and I get A is 28.5, B is negative 256, and C is 373.5. So I have all of this plus 28.5, integral of 1 over x minus 1, which is ln x minus 1, plus b, which is negative 256, And I can pull that out of the integral on this, and I'd have the integral of 1 over x minus 2. U substitution will turn that into ln x minus 2. And c over that. (373.5) integral of 1 over x minus 3, which is ln x minus 3, plus c. All that's added to this. And that would be the antiderivative to b there. And okay, let's do c. I'll do that one fairly quickly here, I think, because that's already factored. So we're going to have a over x minus 3, but it's a repeated, so it's b over x minus 3 squared plus c, and it's 3 times, so x minus 3 to the third. So I'd have to multiply this one by x minus 3 squared, which would be x squared minus 6x plus 9. This one I just need an x minus 3, and this one I would need nothing because it's got the common denominator. So I have x squareds, and of the x squareds I have 1 equals a, none there, none there. So a is 1. X's, I have minus 6. Oh, excuse me, minus 1. Minus 1x, and I have minus 6a plus b, and no x's there. Constant. I have 9a. Oh, the problem has minus 1 for that also, equals minus plus 9a minus 3b plus, and c will be constant. That's the only one. It's just c. Well, that says a is 1. And if a is 1, we've got minus 6 that we can add to the other side. So plus 6 minus 1 is 5. B equals 5. And if a is 1 and b is 5, we've got 9 minus 15, which is minus 6. So we need to add 5 to minus 6 to get minus 1. So the integral of this changes to 1 times 1 over that, which is 1 times ln x minus 3 plus. This is going to be 1 over u squared. B is 5, so 5. And the integral of 1 over x, or u squared, if I do u sub for that, will be u to the minus 1 over minus 1, or minus over u, which is x minus 3, plus 5 over this cubed. So that if I do u sub for this, I'm going to get u to the minus 3, dx equals du. Integral, that's u to the minus 2 over minus 2. U will be x minus 3 squared. Okay. So that was 4 and 6. 7. This is using the tables. So something that looks like this. Well, let's see. A square root in the denominator with pluses. That's kind of like this. And no, that's in the numerator. But we have to have a x in the denominator. Oh, that looks like this one. Except that it's 9x squared instead of u squared. So I'm going to have to let u be 3x because this is 3x squared. So du would equal 3dx divided by the 3. So I'm going to get a 1/3 when I change this to u with u squared. And a from my formula will be 5. And this 3 will make that 3x be a u. And so I get u square root of u squared plus 5 squared, which turns into minus 1 over a. And a was 5. This one, I keep losing it. Ln of a, which we called 5, plus the square root of u squared. Well, that's back plus a squared. That's the same thing we had before, 9x squared plus 25 over u, which is 3x plus c. That's kind of the idea of how you have to do things here. This one, we can make it look like this one if we let u be x squared. So this would be changed to u squared because x squared squared is x to the 4th. So du would be 2x dx divided by the 2x. And this is going to be du over 2x. The x's will cancel, so I'll have a half of this integral of 1, the square root of 1 plus u squared du. The half come from the du over 2, and the x's cancel. So I got this. And according to the formula, 17, this is u, which we said was x squared. And I have a half that I'm multiplying everything by. And so my formula says u squared over 2, and I'm taking it times the half, so it's u squared over 4, square root of what we had to start with, which is 1 plus x to the 4th, plus, so we're doing the plus one, so it'd be plus u, which was a, which was 1 squared, which is 1 of, getting it out of the where you can see it, so let's do this. So a squared, a was 1, squared is 1 over 2, but we also had times a half for everything, so 1 over 4. ln u, which is 2x, no, x squared, plus the square root of x squared plus a was 1 squared, which is 1. Oh, wait a minute. It's u squared, and u is x squared, so this is x to the 4th. This one, if you do u equals e to the x, I think you're going to get the same formula 17. And if you let u be cosine x, you're going to get, I believe, formula 20, I think. So just a heads up on those. And you're going to let u be cosine x, because its derivative is going to be a sine, which is going to cancel the sine and the tangent, and you'll have another cosine, which is u times the square root of 9 minus u squared. And that's going to look like 20. Oh, wait a minute. That's backwards. It's this 20 is not u squared minus 9. We need 9 minus u squared. Not that one. 9 minus 24. 24. So not 20, but 24. Okay,